All right. I don't know. We'll see if I can get this thing going. So it says we have a 5 meter long ladder that has a mass of 6 kilograms and it rests on two sawhorses. The distance one is 0.9 meters and distance two is zero point 0.4 meters. What's the magnitude of the force that the ladder exerts on sawhorse B? All right, so let's just label some things. This ladder has a mass of, and I'm going to do M subscript L, 6 kilograms. And I'm going to label D1. D1 is 0.9 meters. I'm going to label D2. Oh, shoot. Don't want to do that. This is 0.4. And then we said the length of this thing was 5 meters long total. Okay? And what we're really curious about is how much force is being applied right here on sawhorse B. Now to do this, this is a little kind of a tricky situation. So the ladder isn't moving left or right. So an easy way to do this problem is to remember that if I add up all of the torques, because you have over here you have a torque that's pushing down this way, and over here you have a torque that's pushing down that way, because you have gravity pushing here, gravity pushing here. And in a roundabout way, you have some stuff going on over here, because this is a torque. So because the ladder isn't moving at all, the sum of all the torques has to equal 0. So then what we need to do is just add up the torques. So this torque over here on B, it's to find and remember that torque is really just the radius or distance times the force that's applied. Okay? So, and also, if you have a counterclockwise, that's a positive torque. And if you have a clockwise, that's a negative torque. That's important because one of these, in other words, this one coming down this way can be positive or negative, and this one coming down this way can be positive or negative. Okay? So the force that's being applied to B times the radius. So if I say the force B times the radius, well, how do I figure out what the radius is? In other words, we're looking for the force that's being applied here. Isn't that just the length, the overall length, minus D1 minus D2? So that's the force that's applied. That's this. What am I finding? The distance between A and B, right? And that's what I'm trying to figure out is what is the force that's being applied to B? Well, and then I also have this force over here, which would be mg times 1/2 minus d1. And that's, if we add those all up, that equals 0. If we apply all the torques. Okay? And this is a negative torque. So then if I move that to the other side, I end up with, in other words, if I add this to both sides, okay? And I kind of skipped over a couple of things. What this is coming from is that we're choosing A to be the center point, okay? And so if I choose Sawhorse A to be the center point of rotation in order to eliminate the unknown force of force A from the torque equation, then the sum of all the torques at point A due to the gravity and FB, because that's what we're trying to figure out. And that's why the signs get reversed and all that stuff. And that's why we have the 1/2. So if I add both these to both sides, I get in my next line FB minus L minus D1 minus D2 is equal to mg times 1/2 minus D1. Now I know a lot of this information, right? I know D1, I know L, I know D, I know D2, I know M, right? I know the mass of the ladder, I know G, lowercase g, let's write that down over here. That's the acceleration due to gravity, 9.8 meters per second squared going down towards the center of the Earth. And then I know D1. So really I have all that I need. And what am I trying to figure out the force applied to B? Because that's what they're saying. What is the magnitude of the force exerted on Sawhorse B? All right, so let's plug in what we know. Or actually, I think what I'll do, let's solve this algebraically. Let's get FB by itself. So then I'm just going to divide this side by L minus D1 minus D2. And the same thing over here. I've got L1 minus D1 minus D2. So then I get FB is equal to mg 1/2 minus D1 all over L minus D1 minus D2. And when I plug that into, let's plug the numbers in, I'm going to get 6 times 9.8 times 1/2 minus D1, right, which is 0.9, all over 5 minus 0.9 minus 0.6. And when you plug that in a calculator, it ends up being about 25.4 newtons. Okay. Does anybody have any questions on this one? Because even I have to think about where everything comes from. Oops. Does anybody have any questions? Oh, you know what? I screwed up. This is, we've got to do 1/2 of the 5 meters. So Man, they are typing this stuff funny. All right, let me stop. Let me just plug this in the calculator to make sure I did everything right. We probably will need to go back, and I think it's supposed to be point. Let me plug this in the calculator. I think it's supposed to be 5/2. So you could do this in your calculator this way: 6 times 9.8 times. Now, according to this, it's supposed to be in parentheses. I think it's supposed to be 5 divided by 2. I think that's where I messed up because I think it's supposed to be 1/2 of L. But let me double check here real quick by plugging it in the calculator. 0.9, close my parentheses, all over, in parentheses, 5 minus 0.9 minus 0.4. Because when I wrote down the 1/2, I kept thinking, where does the 1/2 come from? And if you were thinking that, yeah, it's 1/2 times L. So let me make the corrections. So this is 1/2. I forgot to write down the L. That's all. I'm sorry, guys. So right here, this is 1/2 times L. This is 1/2 times L. And so 1/2 times L. And then right down here, what's 1/2 times L? Well, let me just clean this up a little bit. That should go, that should go, that should go. So make sure that you make these changes. It should be 1/2 L minus D1. 1/2 times L minus D1. 1/2 L minus D1. And so way down here, this would just be 5/2, right? 5 divided by 2, because L is equal to 5, right? So sorry about that. I wrote down the equation. I kept thinking to myself, what is 1/2? What is 1/2? What is the 1/2? And then I had to think about it as I was teaching you guys. I was like, it's got to be 1/2 the length of the ladder. Okay. Minus D1, of course. Any questions on this one? All right. We'll move on to the next one. Which one was that? Number 12?